Alright, if you are watching this video, it's because you decided that a retake was something that you wanted to do for Unit 1. So I'm going to just briefly explain how the whole process works. Um, the first part that I will do in this video is go through your test, and you may or may not have your test in front of you. Either way, it's fine. But I'm just going to go through the test question first. I'm going to give you some practice problems, so have some sort of sheet out, whether it's in your notebook or something, but have something out to do those practice problems on, because before we can give you the retake, we will have to see your practice problems and check over those and make sure that you got them right before we'll let you do a retake test. Okay. So the first part, just going through, here's learning target 1 from your test. Number 1 is create 2 equivalent expressions to the one below. The most common answers that I saw were people first distributing to get 2x minus 6 plus 4x. That's one of them right there. That's an equivalent expression. From there, you can simplify it one step further and combine like terms and get 6x minus 6. That's another equivalent expression. So right there are 2 equivalent expressions. I saw some people, I think, getting confused with equations, because I would see some people like add 100 and then put equals 100. Keep in mind, these are expressions. This is not an equation. There's no equal sign here, so this is an expression. So you cannot do something like that. If it were an equation, you could, to balance the two sides, keep them balanced, but these are expressions. Part 2 of this learning target was definitely your 4 question. This was definitely like your difficult, like push you to that exceeding level question. The first thing that I would do here is subtract 8 from both sides. We talked in class how you could multiply by y plus 4 first, but that it would be much more complicated because you would then have to multiply that by y plus 4 and that by y plus 4. Okay, and that is really just gonna kind of make things messy in trying to solve this. So I would really recommend subtracting 8 first. Then multiplying by y plus 4. And distributive property gives you this. Add 6 to both sides. You get 2x equals 2y plus 14. Divide everything by 2, and you get x equals y plus 7. So your practice problems for learning target 1 then are right here. Go ahead and pause the video, or if this is the only one you're doing, go ahead and pause it and stop watching. These are the 3 practice problems that we're going to be looking for before you can take the retake. If you're moving on for learning target 2, here's learning target 2 from the test. Solving these equations, this first one went fairly well for most people. It's a basic distributive property problem. So you get 2p plus 6 equals negative 2p plus 66. Probably add 2p to both sides, you get 4p plus 6. Subtracting 6 from both sides, 4p equals 60. Divide by 4, divide by 4p equals 15. On number 2 over here, again, distribute first. And from this point, we can see without even going any further, I've got the same coefficient and constant on the left side. I've got the same coefficient and constant on the right side. So this is infinite solutions. For number 3, this is just like a lot of those practice problems that I gave you after the checkup for this learning target. We talked in class a little bit about it too. You need to subtract 6 from both sides first. If you want to multiply 2, you can do that. I don't discourage that, but it's going to make things a little bit more confusing and you're probably going to forget a step. So I would do this first. Leaves you with x over 2 equals 7.5 minus 6, that's 1.5 or 3/2. Then multiply each side by 2, and x equals 3. Number 4 over here, distribute first. And you can see from this point, without going any further, we have the same coefficient but a different constant. And so because of that, we know that those two sides will never be equal no matter what you put in for a value of t. So no matter what you try to put in for t, those will never be equal, so that is no solutions. Number 5 over here, distribute first, you get negative 5n minus 8 minus 56n equals negative 8. My next step would be to simplify this get rid of this minus 8 right here, add 8 to both sides. Combine like terms here, you get negative 61n equals 0. Now, some people got confused at this point. This does not mean no solutions. Okay, if you were to divide this by negative 61 and divide this by negative 61, you would get an answer, n equals 0. Okay, and that is a perfectly valid solution. N equals 0 is a solution to this equation. Okay, so the answer is not no solutions because 0 is the solution, and 0 can be the solution. Number 6, this one went pretty well for most people, so I'm going to kind of go through it quickly. Not too many issues with this one. For this, you end up with x equals 8. So your practice problems for learning target 2 are right here. You've got 4 equations to solve. Again, same deal when you've finished the practice problems here. Go ahead and bring those to myself, Mrs. Hanson or Ms. Aaron, and we will schedule a retake for you. Learning target 3. Again, this one went pretty well for the most part on the test as well. The first step here is just using distributive property. So we've got this 7 times each part on the inside. So your first thing that you needed to have here was distributive property. And what I'm going to do is outline the kind of most essential justifications here. There were some others that I saw included, or some people talked about combining like terms here and there. That's fine. If what I'm going to outline is the 3 things that you definitely for sure needed in order to get this problem. Okay, so distributive property is the first one. Next, we subtract a 2 from both sides, and we can do that because of the subtraction property of equality. The next step is dividing by 21 on both sides, and we can do that because of the division property of equality. And that gives you the solution. So there are really just these 3 steps in justifying that. So your practice problem for learning target 3 is, again, very similar. It's just here is a solved equation. Go through each part of this and explain how you knew you were able to do each one. Moving on to learning target 4, here are the 3 problems from your test. On number 9, start by adding 7 to both sides. Solve it like a normal equation, except that it's an inequality. You don't have to change the sign because you didn't divide by a negative. And on my number line, I would just include 5, 6, and 7. It's going to be an open circle because this is not greater than or equal to, it's just greater than. And then I'm going to shade to the right because I want the values that are greater than 6. For number 10 over here, start with just the basic addition property of equality, these kind of steps for solving. The one thing that's a little bit different about this one is I'm dividing by a negative here. And so since I'm dividing by a negative, I do have to flip the sign. So that flips this sign from being a greater than equal to a less than equal to. And 12 divided by 4 is negative 3. So my answer, x, is less than equal to negative 3. And so since it's less than equal to, this is going to be a filled in circle. And x is less than negative 3. So I'm going to shade to the left. In the last one, I'm going to do distributive property first. Subtract a 12 from both sides. You get 9 is greater than equal to 3x. Divide by 3 and divide by 3, and you get 3 is greater than equal to x. Now this was a part that sort of tripped some people up from this point. So if I make my number line there, a lot of people shaded this incorrectly. And I think the reason for that is because the x is now on the right side instead of these other two where x was on the left side. So this one you just kind of have to think about this answer right here and basically what does this mean? This means that 3 is greater than or equal to x. Okay, so try these 2 different points. Try 4. If you plug in a 4 for x, is 3 greater than or equal to 4? No, 3 is less than 4. Okay, so 4 does not work. So I don't want to shade to the right because I'd be including a value that does not work. So I'm going to end up shading to the left, and I can test that with putting in 2 for x. If I put in a 2 right here for x, 3 is in fact greater than or equal to 2. Okay, so 2 should be included, as should 3. So that's why it's a filled in circle, shaded to the left. Practice problems for learning target 4 then. So again, give these a try. After you've done these, we will check over them, make sure that you've kind of got your kinks worked out and you know what you're doing. And then we will give you the retake for learning target 4. Learning targets 5 and 6, I'm just going to kind of do at the same time. They're fairly closely related. In adding and subtracting polynomials, in class we talked about how this is basically just combining like terms. So we've got a 7x squared, and then later we're going to add an x squared. So that's going to give me a total of 8x squared. I've also got a minus 2x, or you can think of it as a negative 2x, plus a negative 3x for a total of negative 5x. The last part is the constant term. So I've got a 5, a positive 5, plus a positive 12 for a total of 17. On the second part of this learning target, we're doing a subtraction problem. These are typically a little bit more challenging, but it's the same sort of thinking that goes into it. I'm going to start with an x squared. Later I've got a 2x squared, but this is a minus between them. So I've really got a x squared minus 2x squared for negative x squared, negative 1x squared. I've got a 10x here, a positive 10x, and later I'm going to subtract 6x. This was something that kind of tripped some people up too. This minus applies to everything on the inside of the parentheses. So I'm not just subtracting the first part, I'm subtracting every single part on the inside. So really what that leaves me with is a 10x minus positive 6x, or minus 6x, for a total of 4x. The last part is the constant. I've got a positive 12 minus a negative 6, and when we minus a negative, it turns into plus a positive, so this becomes a plus 21. For multiplying, learning target 6, multiplying polynomials, this first one you can just do a distributive property 3 times. 10 times 4x squared is just 40x squared. 10 times 7 is 770x. And then you've got a plus 2 on the end. 10 times 2 is just 20. Plus 20. On number 15, this is where you could either use FOIL or distributive property twice. The first part, x times x, is x squared. Okay, that was a mistake that some people made. X times x is x squared, not 2x. X squared. The second part would be x times negative 2, or minus 2x. Next we've got a negative 8 times x, negative 8x. And then we've got a negative 8 times a negative 2 for a positive 16. The negatives here are were probably the most common mistake that I saw on this part of the learning target. Just distributing the negatives, carrying the negatives with the 8 or with the 2 was probably the toughest part. The last step then, and some people forgot to do this as well, but just combining like terms here. So you've got a negative 2x and a negative 8x. That gives you a total of negative 10x. And your answer is x squared minus 10x plus 16. There is no retake for learning target 7. Learning target 7 was something that we talked about on a pretty basic level. We talked about those several different times, and so there is actually no retake for learning target 7. Oh, here are your practice problems for learning targets 5 and 6. You don't have to do them together. Like you could do just learning target 5 or just learning target 6 if you wanted. But there are those if you're interested in that. Learning target 8. Solving equations with square roots. Number 15, or the first one here, the first thing I would do is subtract a 10 from both sides. You do not want to square root this first because you'll end up having to square root the entire side, including the 10, and that's not really something that we know how to do yet. Okay, so just like on learning targets 1 and 2, you want to get rid of the constant, and you want to make your square rooting the last possible step. So that leaves you with an x squared equals 81. Now you can square root both sides because you know that there's nothing left here besides just square rooting. So go ahead and square root both sides to get rid of this squared symbol. That all cancels out. And you're just left with x equals square root of 81, which is plus or minus 9. There's always a plus or minus when you are square rooting something. There are two possible answers. So that was a big thing that people missed too. On number 16, same sort of concept. We want to first subtract 3 from both sides. That gives you square root of x equals 1. And to undo a square root, we square both sides. Similar to the last one, that all cancels out, and we're left with x equals 1 squared, which is just 1. On learning target 9, we can kind of think of this again as combining like terms. So on number 19, I've got 4 square roots of 5, and then later I'm adding 6 more square roots of 5. So you don't change anything under the radical. The radical stays exactly as it is, exactly the same. And it's sort of like just saying I've got 4 of these and then 6 more of these, so total I've got 10 of these. Number 20, when you multiply square roots, you do actually change what's under the radical. Okay, so make a big radical and you multiply what's in between, or what's in the middle of each one. So that gives you square root of 30 for your answer. That cannot be simplified at all. We talked about simplifying radicals some. Square root of 30 cannot be simplified because it doesn't have any factors that are perfect roots. On number 21, we will see something that does though. Okay, but first, simplifying, you can put it all under one square root symbol. That is the same as square root of 50. Now we can simplify this because this simplifies down to square root of 25 times square root of 2. And we know that the square root of 25 is plus or minus 5. So we've got plus or minus 5 square root of 2 as the final, most simplified answer there. Number 22 is distributive property. So that first step gives you square root of 2 times square root of 2. Copy down the plus. Square root of 2 times 3 square root of 5. Square root of 2 times square root of 2 is the square root of 4, which is just 2. Okay, if we know square root of 4, and technically this is a plus or minus 2. Plus or minus 2. Square root of 4 is plus or minus 2. Copy down the plus. Over here, combine what's under the square roots and multiply them. There's nothing out in front of the 2 to combine with the 3, so this just remains a 3. 2 times 5 is 10. So your final answer for that one is plus or minus 2 plus 3 square root of 10. Here are your practice problems then for learning targets 8 and 9. Again, same deal with these. Do these on a separate sheet of paper, bring them to your algebra teacher, and then we will check them, make sure that you kind of know what you're doing, and then give you the actual retake test.